Assalamualaikum warahmatullahi wabarakatuh. How are you guys? I hope everyone stay healthy and stay safe. Today I will present the result of the chemistry journal review. Before, let me introduce myself. My name is Indah Putri Anggraini, NPM 8. I'm from class B. Okay, I want to explain to you a component of a paper. First, name of journal, Journal of Environmental Management. Next, title of article, Green synthesis of iron nanoparticle by extract polyphenol and its selective removal of cation dyes. Authors, Chang Yuan Xiao, Haiyan Li, Yan Zhao, Xing Zheng, and Xiao Yuwang. Keyword, green synthesis, iron nanoparticle, T polyphenol extraction, microwave methods, and selective removal. Next, introduction. With the latest development of nanotechnology, the synthesis and application of nanometer zero valent iron has become the focus of global attention. It is widely used to remove a variety of pollutants, such as heavy metals, antibiotics, chloroorganic, bromides, nitrates, and dye pollutants. As traditional method, liquid phase reduction has been used to prepare nano iron particle, but its chemical reagent consumption is large, the cost is high, and the generation of toxic byproduct poses a potential threat to the environment. Besides this, the magnetic force between iron particle usually leads to the aggregation, which has become the major obstacle to the practical application of iron nanoparticle technology. Thereafter, the surface modification of iron nanoparticle with dispersion was studied in depth. However, non-biodegradable dispersion are considered to have sufficient toxicity and, if used on a large scale, could cause secondary contamination. As one of zero valent iron synthesis alternative, the reduction of iron or ferrous iron using bioactive substance obtained from plant extract. The extract has emerged the most suitable reductant and stabilizer for green synthesis because it is in active polyphenol and caffeine. Polyphenol are powerful antioxidant, and free radical scavengers. The reduction potential of epicatechin, the most important component of T polyphenol, is 0.57, which is sufficient to reduce Fa2 plus to Fa0. Iron nanoparticle can be readily prepared against aggregation using plant extract, polyphenol, and caffeine as intrinsic reductant and dispersant. Herein, the green biosynthesis of Fa nanoparticle by different T extract, polyphenol, and caffeine obtained from a novel microwave method was studied because compared with the commonly used solvent extraction and metal ion precipitation method, microwave extraction has the characteristics such as high efficiency, energy and solvent saving, as well as short treatment time. It conforms to the concept of cleaner production and reduce the potential harmful effect on the environment. And next, materials and method. Materials. The materials that used in this study are ammonium molybdate H8MON2O4, ferrous sulfate heptahydrate FeSO4 7H2O were purchased from Al chemical reagent. Malachite green Mg, methylene blue Mb, rhodium BRB, methyl orange MO, Cr, and bromocresol green BCG were from Sinopharm chemical reagent Beijing. Sodium acetate CH3COONa and acetic acid CH3COOH were purchased from Beijing Chemical Works. Deionized water as solvent, and all reagents used were analytical grade. Puerau T. Camellia synthesis for Acemica and black tea, Ceylon black tea, Yunnan Matcha tea, Longjing, Camellis sinensis, white tea, and dark tea were purchased from the Walmart supermarket in Changchun. And next methods: A. Extraction and determination of tea polyphenol. The tea was crushed into powder, immersed in distilled water, then extracted in a microwave chemical reactor. The tea extract was obtained by vacuum filtration after cooling. Effect of temperature 60 degrees Celsius to 80 degrees Celsius. Time 8 minutes to 16 minutes. Power 240 to 560, and solid liquid ratio 1:20 to 1:30. The concentration of the polyphenol was determined by ammonium molybdate spectrophotometry. Reaction condition 0.10 gram per liter. The polyphenol standard solution, ammonium molybdate solution 100 milligrams per liter. Hydrogen AC NaAC buffer pH 3.5 and maximum absorption wavelength 341 nanometers. B. Preparation of Fe nanoparticle by tea extract. The Fe nanoparticle were prepared by mixing tea extract with 0.1 mol per liter FeSO4 solution at a volume ratio of 2:1 and then oscillating in a shaker at 298 K for 30 minutes. The reaction liquid changed from yellow to black. Solid nanoparticles were obtained by washing product with absolute ethanol and deionized waters, and then vacuum drying for more than 12 hours. C. Characterization. The microstructure and size of the samples were characterized through GCM 7500 scanning electron microscope. The elements of surface were detected by energy dispersive spectrometer. The crystalline state of the sample was analyzed by X-ray diffraction. D per max 2500. Surface functional group in tea extract and sample were checked by Fourier transform infrared spectroscopy. The chemical state of the element was determined by X-ray photoelectron spectroscopy. The zeta potential of sample was observed with zeta Caesar nano at different initial solution pH value to 10. The concentration of dye in solution was determined by UV vis spectrophotometer UV 2600. The batch experiment. The removal experiment were performed by adding 0.01 gram the iron nanoparticle synthesized using green tea extract Fa nano PS GT to 40 milliliters aqueous solution and setting the dyes Mg, methylene blue Mb, rhodiamond B, Rb, methyl orange MO, Cr, bromo cresol green BCG, and each other with the same original concentration of 50.0 milligram per liters. Then the conical flakes were shake on the speed of 200 rpm at 25 degrees. The removal rate of dye by Fa nano PS GT were calculated by detecting the change of dye in solution. The concentration of dye was probed by ultraviolet visible spectrophotometer UV 2600. Next result from the XRD patterns of Fa nano PS GT synthesized from green tea extract GTA, suggesting that the organic in GTA are encapsulated on the surface of iron nanoparticle and acted as a stabilizer. Fa nanoparticle GT was stable and reliable in the process of cationic dye decolorization, which was mainly due to the oxidation resistance of the polyphenol and caffeine. The removal mechanism of Fa nanoparticle GT on cationic dyes was better fit to pseudo-first order models. The polyphenol can not only be used as reductant to produce Fa nanoparticle with low biotoxicity, but also play the camping role to enhance the stability and oxidation resistance of Fa nanoparticle. The prepared Fa nanoparticle GT exhibit excellent selective removal ability towards cationic dyes. The surface of Fa nanoparticle GT is negatively charged, so positively cationic dyes are easily to be attracted to adsorb on it. Firstly, these dye molecules are adsorbed on the reactive site on surface of Fa nanoparticle GT containing iron oxide and tea extract. The Fa nanoparticle synthesized under different atmosphere, nitrogen or oxygen, have different removal efficiency on dyes. The formation and properties of iron oxide kept on the surface of iron nanoparticle affect the interaction with dyes. However, in the presence of oxygen, iron nanoparticle can still achieve a good dye removal effect. Secondly, Fa0 reacted with H2O and lost electrons, which were used by H+ to generate active hydrogen with strong reducibility. Finally, electrons from active hydrogen were accepted by certain cationic dye molecules. And the last conclusion, the Fa nanoparticle GT have good selective removal capacity and high grade toward cationic dyes such as malachite green Mg, methylene blue Mb, and rhodamine BRB, and the OE reach 190.3 milligram per liters, 186.93 milligram per liters, and 182.4 milligram per liters, respectively. The possible removal mechanism mainly involves adsorption and reduction process. It suggests that the Fa nano PSGT may be an environment-friendly material for effective treatment of cationic dyes wastewater. Okay, that's the presentation from me. Sorry if there are many mistakes. Wassalamualaikum warahmatullahi wabarakatuh.